So now, for this last video, we're going to be finding complex roots of quadratic equations. We have the equation f of x is equal to x squared minus 2x plus 5. Well, first we're going to look if we can factor it, which we can't because, I already told you it's going to have some complex roots. So we're going to go with the method of solving this that we just learned about in the last lesson, which is by completing the square. First thing I want to do is I'm going to set this equal to 0. And now since our a equals 1, I don't have to do anything with that. I can go straight into moving this 5 over here. I'm going to subtract 5. I'm going to leave a space for my new c. And now I want to figure out what this new c is going to be. I'm going to find that by taking b over 2 and squaring it. And then I will have a negative 2 over 2 giving me negative 1. Square that and I will have 1. And my 1 is going to come over here. So I'm going to add 1 here and I'm going to add 1 here. Giving me x squared minus 2x plus 1 is equal to negative 4. So now I can factor this. Draw my parentheses. I'll have x plus 1. Oh, no, there's a minus sign. X minus 1 squared is equal to negative 4. I want to simplify this. I'm going to take the square root of both sides. And when I do that, these will cross out. So I'll have x minus 1 is equal to the square root of negative 4. The square root of negative 4, let's figure that out over here. Square root of negative 4 is equal to the square root of negative 1 times the square root of 4. I know that the square root of negative 1 is I. I know the square root of 4 is 2. So the square root of 4 is going to be equal to plus or minus, ooh, that's ugly, plus or minus 2i. I'm going to erase some of this and rewrite it up here. This is going to come up here. I'll have x minus 1 is equal to plus or minus, we just found out that the square root of negative 4 is 2i. One more step to get x by itself. X, we're going to add 1 to each side. X is equal to, and now remember I said I would prefer to have our real numbers in front, so 1 plus or minus 2i. And that's your final answer. And now notice when we have this, our 1 plus or minus 2i, that's going to give us 2 roots. What are those 2 roots? That's going to give us x equals 1 plus 2i and x equals 1 minus 2i. These 2 numbers are called complex conjugates. This and this are called complex conjugates. What that means for them to be complex conjugates is that the real part, so 1 and 1, those are equal. And our imaginary part, plus 2i and negative 2i, are opposites. Whenever you have complex conjugates, this will be the case because that is the definition of it, that the real part is equal and that the imaginary parts are opposites. Similarly, if quadratics have complex roots, those roots will be complex conjugates. And then if you know one complex root, how can you find the other one? You just need to find its conjugate. So, for example, if I knew that one of the roots of a complex, if one of the complex roots of a quadratic equation was 7 minus 5i, how would I find the other one? I would find its conjugate. And, simple enough, really easy. The real parts have to be equal, And the imaginary parts have to be the opposite. I have a negative 5i, my conjugate will be plus 5i. That's your answer. One more. If the square root of 3 plus 1 was one complex root of a quadratic equation, I need to find its conjugate. The real part, square root of 3 is equal, or is real, haha. Square root of 3, the real part needs to be equal, square root of 3, and my imaginary part, I, needs to be its opposite. I have a positive I, the opposite will be a negative I. And that's your answer. Okay, I want to do one more example of finding complex roots of quadratic equations. So let's say I have the equation f of x is equal to 4x squared minus 3x plus 1. This one's going to be heavy, trust me. All right, first step, set it equal to 0. Our a doesn't equal 1. It's a 4. So I need to divide this whole thing by 4. When I do that, I'm going to have x squared minus 3/4 x plus 1 over 4 is equal to 0. Okay? So now that our a equals 1, I can move my c to the other side. Leave a space for your new c is equal to negative 1 over 4. Okay, I want to find what my new c is going to be. And I can find my new c by taking b over 2 squared. My b is negative 3 over 4. So negative 3 over 4. And then I want to divide that by 2. But can we divide a fraction by 2? No. What do? We multiply by the reciprocal. What is the reciprocal of 2 over 1? We're going to multiply by 1 over 2. When I do that, I have negative 3 over 8. Woo! And I need to square that. When you square something, you're just taking that number by itself, times itself. So this will be negative 3 over 8 times negative 3 over 8, which gives me 9 over 64. I'm going to add 9 over 64 into here. When I do that, I will have x squared. I need some space. When I do that, I'm going to have x squared minus 3 over 4x plus 9 over 64 is equal to negative 1/4 plus 9 over 64. So the first thing I want to do is I want to add these two together. And I'm trying to add negative 1 over 4 plus 9 over 64. When I'm adding two fractions, I need to have a common denominator. So in order to do that, I need to multiply negative 1/4 by 16, leaving me with 16 times negative 1, negative 16 over 64, plus 9 over 64. Whew. That's going to equal negative 16 plus 9, negative 7 over 64. I'm just going to write that in here. Okay. Once we've got to here, we can factor. I'm going to factor this. Now it's going to be a perfect square. So I'm going to write my parentheses, and I'll have x minus, and now I obviously don't have it up here, but if you look back, what was our b over 2 before we squared it? It was negative 3 over 8. So b minus 3 over 8 is equal to, oh, that's supposed to be squared, is equal to negative 7 over 64. Okay, so let's solve for x. How am I going to do that? I'm going to take the square root of both sides to start out with. So the square root of this, square root of that. These are going to cross out. X minus 3 over 8 is equal to the square root of negative 7 over 64. Let's look at what is the square root of negative 7 over 64. Well, I can start by rewriting this as the square root of negative 7 over the square root of 64. And I know that the square root of negative 7 can be written as negative 1, the square root of negative 1 times 7 over the square root of 64. I know that the square root of negative 1 is I. And the square root of 7, we can't simplify that anymore. And what is the square root of 64? 64 is a perfect square. The square root of that is 8. So, I'm going to bring this back over here. And it's going to be equal to plus or minus, I should have put my plus or minus in there sooner, I apologize. Plus or minus I square root 7 over 8. Our last step to get x by itself is going to be to add 3a's. So I'm going to add 3 over 8 to this side, and I'm going to add 3 over 8 to this side. When I do that, these are going to cross out, cancel out of me. We'll be left with x equals, when we're just adding two fractions here. So when we're doing that, we just need to make sure that they have the same common denominator, which they do, 8 and 8, and we're just going to write it. We're going to bring this 3 to the front, so x is going to be equal to 3 plus or minus I square root 7 over 8. And that's going to be your final answer. Good luck!